is beta hydroxycarbonyl compounds. Beta hydroxycarbonyl compounds. Beta hydroxycarbonyl compound alpha beta hydroxycarbonyl compounds. Beta hydroxycarbonyl compounds undergo 1,3-cc disconnection. 1,3-cc disconnection. The bond will be disconnection takes place here. Negative, positive, negative. Then the product is hydrogen heat aldehyde. This will be aldehyde and this will be acetone. Now synthesis of this molecule is when acetone reacting with base, sodium hydroxide or potassium hydroxide, base abstract the proton from here, then produces alpha carbon ion. This alpha carbon ion undergo keto-enol tautomerism, then produces enol. Okay, this is enol, this is a keto. This keto-enol tautomerism, when reacting with another mode of aldehyde, this negative charge attack it here and bond shifting to oxygen side. Then the product is OH, C double bond OH. This is a beta hydroxycarbonyl compound will be formation takes place, target molecule. So this is the second example for the 1,3 difunctional disconnections. Okay, next one is one-four difunctional disconnection. One-four difunctional disconnection. For difunctional disconnection. 1,4 difunctional disconnection. In this 1,4 difunctional disconnection, in 1,4 difunctional disconnection, 1, 2, 3, 4. 1,4 diketones, dicarbonyl compounds, 1,4 dicarbonyl compounds when undergo disconnection, then the bond will be disconnection takes place here, negative, positive, negative, positive. So therefore, then that is one is negative charge part, another one is positive charge part. Okay, when these compounds are taken, synthetic equivalents are CH3 and synthetic equivalent is the synthetic equivalent. Now synthesis of this target molecule. Synthesis of this target molecule is when acetone reacting with alpha halo acetone, when in presence reacting with base abstract the proton from here, then that produces a net alpha carbon anion. This alpha carbon anion reacting with another starting material involves in displacement of halogen function. Then the product is 1,4 dicarbonyl compounds will be formation takes place. This is one example for 1,4 difunctional compounds. Next example for 1,4 dicarbonyl compound is gamma hydroxy carbonyl compounds. Gamma hydroxy carbonyl compound. When gamma hydroxy carbonyl compound, alpha, beta, gamma hydroxy carbonyl compound, when undergo here bond will be breakage takes place. Then the product is here negative charge and positive charge. So this is synthon is hydrogen, my negative charge, positive charge here. Therefore, epoxide is the product will be formation takes place. Synthesis of this compound is when carbonyl compound reacting with base abstract the proton from here. then the produces alpha carbon anion. This alpha carbon anion attacking at epoxide, then bond will be open takes place. Then the product is alpha, beta, gamma hydroxycarbonyl compound will be formation takes place. This is the example for the uh, uh, 1,4 difunctional compounds. Next, 1,5 difunctional compounds. 1,5 1,5 1,4 difunction 1,4 difunctional compounds. 1,4 difunctional compounds in 1,5 difunctional compound. Sorry, 1,5 difunctional compound. In 1,5 difunctional compound, alpha beta bond will undergo disconnection. Okay, this is a trick for 1,5 difunctional compound. Difunctional compounds, while alpha beta bond undergo disconnection takes place. Best example I am given here. 1, 2, 3, 4, 5, 1,5 difunctional compounds. Here, alpha beta bond undergo disconnection takes place. When alpha beta undergo disconnection, then produces alpha beta unsaturated carbonyl compounds and acetone. When the acetone reacting with the base sodium hydroxide or potassium carbonate, base abstract the proton from here, then produces alpha carbon anion. This alpha carbon anion undergo Michael addition, alpha beta position of undergo Michael addition, Michael addition, undergo Michael addition. The addition of nucleophilate beta position of carbonyl compound is Michael addition. Then the product is 1, 2, 3, 4, 1,5 dicarbonyl compound will be formation takes place. Next example for 1,5 difunctional compound is next example for 1,5 difunctional compound is when this is the compound I am taken. Now this is the first example, second example. In the second example, when this compound undergo disconnection takes place, alpha beta bond undergo disconnection takes place, then the product will be alpha beta unsaturated carbonyl compounds and acetic acid in the product. Acetic acid is the acetic acid in this acetic acid methyl attached to electron withdrawing group. Therefore, when reacting with the base abstract the proton from here, then produces alpha carbon anion with respect to electron withdrawing group. This alpha carbon anion reacting with the alpha beta unsaturated cycloketone that undergo beta addition at beta position of alpha beta unsaturated carbon. It is undergo Michael addition. Then the product is CS3 will be formation takes place. This is the product will be formation. This is the synthesis of target molecule. Examples for 1,5 difunctional compounds. When Next, next is 1,6 difunctional compounds. 1,6 difunctional compounds. Next, 1,6 difunctional compounds. In this 1,6 difunctional compounds, 1, 2, 3, 4, 5, 6. 1,6 difunctional compound. In this 1,6 difunctional compound, undergo recognized undergo re, reconnecting strategies, then produces cyclohexene. This cyclohexene undergo Diels order under transform, undergo Diels order transform, then produces dinine, dinophenol will be formation takes place. This is one example for 1,6 difunctional compounds. Okay, next we are going to discuss. Next unit 14. Unit 14, that is applications of some important strategies in organic synthesis. Applications of some important strategies in organic synthesis. Applications of some important strategies in organic synthesis. This is unit 14. Unit 14. In this unit 14, first we are discussing chemoselectivity. Some important terminologies are there. So compulsory one question from this unit. Compulsory one question. One question compulsory from this unit. So that is chemoselectivity, regioselectivity, stereoselectivity, cyclization, reaction, and reversal of polarity. Three terminologies are there. We are discussing one by one. First one is chemoselectivity. 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 Chemoselectivity means, definition for chemoselectivity: the attacking reagent preferentially react with one function group. Attacking reagent preferentially react with one function group by leaving other competitive function group is called chemoselectivity. Attacking function group, attacking reagent reacting with preferentially one function group by leaving other competitive function group is called chemoselectivity. Best example I am taken here. When I am taking one compound, in this compound, two function groups are there. One is ester, one is carbonyl compound. When this compound reacting with lithium aluminum hydride, both the function groups undergo reduction takes place, then produces alcohols are the products. When this compound reacting with sodium borohydride, when sodium borohydride preferentially react with preferentially reacting ketone by leaving other competitive function group, that ester. Therefore, this is the chemoselectivity. Chemoselectivity. This is a chemoselectivity. What is the chemoselectivity? Attacking reagent preferentially reacting with one function group by leaving other complete function group is called chemoselectivity. This is the best example for chemoselectivity. Next example I am taken when paraminophenol, when this paraminophenol reacting with acyl chloride in presence of triethylamine, acyl chloride in presence of triethylamine. So in these two function groups are there. Phenol and OH and NH2 function groups are there. But this acyl chloride preferentially react with the amine function group, but by leaving other competitive hydroxy function group. Then produces paracetamol is the product. also example for chemo chemo selectivity. This is an example for chemoselect. Here, two function groups are there, hydroxy group and amine group. But SL group preferential react with amine group by leaving other hydroxy group. Okay. Therefore, the acylation takes place amine only, not at hydroxy group. This is one of the example for chemoselectivity. Next one is regioselectivity. Next one is regioselectivity. Regioselectivity means any chemical reaction which produces unequal amount of structural isomers. Any chemical reaction which produces unequal amount of structural isomers, then it is called regioselectivity. Any chemical reaction which produces unequal amount of structural isomers, that is called regioselectivity. Okay. Second example is regioselectivity. Any function group, any chemical reaction which produces unequal amount of structural isomers, then that reaction is called regioselectivity. This is a target molecule. In this target molecule, undergo retrosynthetic analysis, the bond will be disconnection takes place here. The bond will be disconnection takes place here. And then the product is, and the product is and the product is benzyl halide. Now, synthesis of this reaction is when compound reacting with the base subtract that two carbonyl alpha position of carbonyl, two hydrogens are there, two alpha positions are there, alpha dash two positions are there. So here two alpha dash positions are abstract the proton here by the base. Then the product will then produces carbon ions are the formation takes place. This is the first one carbon ion, the second carbon ion, it will be reduction takes place. This carbon ion undergo enolation, then produces enolate, then it is undergo ketoenol tautomerism. Then so this enol is stable, this enol is unstable, this enol is unstable, this is stable. Therefore, when reacting with the when benzyl halide, then the produces our target molecule. Our target molecule is a majorly, and when reacting with the benzyl bromide, then produces. So this is a minor product. Okay, minor product. This is a best example for regioselectivity. Any chemical reaction which produces unequal amount of stereoisomers, then that reaction is called any chemical reaction which produces unequal amount of structural isomers, then that is called regioselectivity. Okay, any chemical reaction between two types of structural isomers will be formation takes place. Benzylation takes place at alpha position. Alpha position here in this benzylation takes place alpha dash position. Therefore, these two are the unequal amount of structural isomers. Therefore, this reaction is the come under the regioselectivity category. Next one is stereoselectivity. Next one is stereoselectivity. 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 Any chemical reaction which unequal amount of stereoisomers. Any chemical reaction which produces unequal amount of stereoisomers, then that reaction is called stereoselectivity. Any chemical reaction which produces unequal amount of stereoisomers, then that reaction is called stereoselectivity. Okay. Then that stereoselectivity, example for stereoselectivity are examples for stereoselectivity are when this compound undergo epoxidation, metachloroperbenzoic acid. Epoxidation takes place at this double bond from alpha side only, because here bulky group methyl group is there, bulky group tertiary butyl is there. Therefore, epoxidation takes place from alpha side only. This is a major, and this is will be the minor. This is a major. This is minor. Okay, this is one example for stereoselectivity. Okay, when you take another example, cis alkene undergo hydroxylation with cis alkene undergo hydroxylation with osmium tetroxide followed by hydrolysis, then produces cis diols are the major will be formation takes place. Cis diols are the major will be formation takes place. These are the major will be formation takes place. Cis diols. When trans diols are minor will be formation takes place. Okay, these are the best example of stereoselective reaction. What is stereoselectivity? Any chemical reaction which produces unequal amount of stereoisomers. Any chemical reaction which produces unequal amount of stereoisomers, then that is called stereoselectivity reaction. Next one is cyclization. Next one is cyclization. Next one is cyclization. Next one is cyclization. Cyclization reaction. Formation of a ring formation from acyclic molecule is called cyclation. Formation of ring formation from acyclic molecules is in synthesis called cyclization reactions. Okay, ring, ring synthesis. Ring formation from acyclic molecule in synthesis is called cyclization. So cyclization is the two types: intramolecular cyclization, intermolecular cyclization. Intramolecular cyclization means within the two molecule ring formation takes place. That is called intramolecular cyclization. Intermolecular cyclization means within the ring cyclization formation cyclization takes place. That is called intermolecular cyclization. Intramolecular cyclizations are controlled by kinetics and thermodynamical factors. Intramolecular cyclization are Intramolecular cyclizations are controlled by kinetic and thermodynamical factors. Okay, within intramolecular cyclizations are controlled by kinetic and thermodynamical factor. Three-membered ring formation is highly Three-membered ring formation. Three-membered ring formation is highly favored in kinetical factor, highly disfavored in thermodynamical factor due to steric strain. Four-membered ring is not favored in kinetic as well as thermodynamical factor because they are the reactive centers are always 1 to 4 positions. They are in trans to each other. So and 5 and 6 membered rings formation are favored in kinetical as well as thermodynamical factors. Okay, that means intramolecular cyclations are controlled by thermodynamical and kinetical factors. Three-membered ring formation is kinetically, highly disfavored in thermodynamical factors due to strain in the molecule. In a four-membered ring formation, not favored in both kinetical as well as thermodynamical factors because the reactive centers 1, 4 positions are adapt in opposite configuration. 5 and 6 ring formation are kinetical favored in kinetical as well as thermodynamical factors. Okay, three-membered ring, that means ring size, kinetic factor, thermodynamic factor. Ring size, three-membered ring, four-membered ring, 5, 6, 7. Three-membered ring highly favored in kinetically, highly disfavored in thermodynamically. Four-membered disfavored in both. Five-membered, six-membered are highly favored in both catalysts. When synthesis of three-membered ring, first example is synthesis of three-membered ring. When three-membered ring is synthesized from alkenes, when it is reacting with metachloroperbenzoic acid. When alkenes reacting with MCPBA, then epoxidation will be takes place. Second one is synthesis of five-membered ring. Synthesis of five-membered ring. When this five-membered ring synthesis is when it is undergo retrosynthetic analysis, when it is converted into OH, then synthesis of this molecule is SOCl2, then converted to chlorine. When reacting with H2S, loss of 2 moles of HCl, then the product is five-membered ring will be formation takes place. Next one, six-membered ring formation. Six-membered ring formation. Morphine is a morphine. When this morphine in the six-membered ring formation, the bond will be disconnection takes place like this. Then the product will be 2 moles of epoxide and ammonia. When we take ammonia, 2 moles of epoxide, attack it here, the opening of the epoxide ring will be takes place. NH, OH, OH, NH. Now it is undergo in presence of H2S for loss of water molecule. Then the product is this morphine will be formation takes place. So these are examples for six-membered ring formation. So in I'm taken four-membered ring. For example, in four-membered ring, so in this four-membered ring, the reactive centers. These are first, second, third, fourth active centers. These are in trans to each other like this, trans to each other. So therefore, four-membered ring is highly disfavored in kinetic and as well as thermodynamic factors. Next one is reversal of polarity. Last one is reversal of polarity. Reversal of polarity. Reversal of polarity. So under normal condition, carbonyl carbon of aldehyde is the electrophilic center and can be used as a synthetic equivalent of like this. In carbonyl carbon, generally carbonyl carbon, we are taken as a negative charge. In the retrosynthetic analysis, we are taken as a like this. This is synthetic synthan for the carbonyl carbon. But in this some of the times the carbonyl carbon possessing negative charge. Carbonyl carbon we possessing negative charge in some of the cases. That means at the same number of the same carbon atom, uh, polarity is the reverse takes place. Polarity is the reverse takes place. Therefore, it is called reversal of polarity. Best example I am taken here when aldehyde when aldehyde is reacting with diethane. When aldehyde reacting with diethane, this is a diethane. When aldehyde reacting with the diethane in presence of acid medium, it is involves in loss of water molecule. It is involves in loss of water molecule, then forms an intermediate, an intermediate. When it is reacting with a strong base like phenyl lithium or butyl lithium, N-butyl lithium, so base abstract the proton from here, phenyl abstract the proton from here, or butyl abstract the proton from here, then here here phenyl or and negative charge. In this carbonyl carbon, due to that here partially negative, partially positive. Carbon is electrophilic nature. In this, the carbonyl carbon is nucleophilic nature. In the same carbon, in the same carbon atom, the polarity will be the reverse takes place. Therefore, it is called reversal of polarity. When negative charge is there, when reacting with any electrophilic center, an electrophilic center, any electrophilic center like car carbon positive charge, then followed by hydrolysis, then produces ketone is the product will be formation takes place. Okay, these are reversal of polarity. That means in generally carbonyl carbon is a positive charge, but in some cases the carbonyl carbon is a negative charge. The carbonyl carbon is a negative charge. That means the same carbon atom, the polarity is the reverse takes place. Therefore, it is a reversal of polarity. Best example, then aldehyde in carbonyl carbon is a positive charge will react in diethane and then forms thio um, thioester will be formation takes place. This thioester reacting with in strong base like n-butyl lithium or n-butyl lithium or phenyl lithium, that carbonyl carbon getting negative charge. The carbonyl carbon is a negative charge. So negative charge. This that means if the here positive charge, here negative charge. That means the same number of the same carbon atom, the polarity will be reverse takes place. The negative charge reacting with other electrophilic center, then hydrolysis, then produces ketone will be the production will be takes place. This is also this reverse polarity is very important in synthesis of organic molecules. Okay, so today we are discussing 2 units. Okay, thank you. Next class we are discussing remaining that is aim synthesis conversion and convergent synthesis and some in selective synthesis. Okay, thank you. Next we are discussing next topic.